Hello, welcome to the video. In this lesson, we're looking at section 10.6, where we're going to be looking at segment relationships in circles. So, yeah, on 10.5, we discussed angle relationships with circles. Now we're going to be looking at the value of the segments. Again, with relationships with circles. Again, talking about the different types of intersections that we can have with segments with circles. You remember we could either have an intersection on the inside of the circle, you could have an intersection on the outside of the circle, or you could have an intersection simply on the circle. So here, there, and there. All right. With that, there are different theorems in order to determine the value or values of different line intersections in those particular instances. So the first one we're going to be looking at is a theorem that is based off of where the intersections on the inside of the circle. So if you have two chords and they intersect on the inside, they're saying that you can find the value of the intersected pieces by saying, all right, that EA times it by EB, so it's what those values are along those same line segments, is equal to the product of EC times it by ED. Again, that's on the same line segment. So from here, they're asking us to find the values of ML, which is this line segment here, and JK, which is this line segment there. So with that, we need to find the value of X. So MN is X plus 2, so I'm going to say that X plus 2 times it by X plus 1 is going to be equal to X times it by X plus 4. So again, it's just using that theorem to help us out. So because we have some binomials here, we're going to have to FOIL on the left side. We'll distribute it on the right-hand side when that happens. So on the left-hand side, it turns into X squared plus 3X plus 2. On the right-hand side, we get X squared plus 4X. Luckily, we can subtract X squared to both sides to be canceled. What I'm going to do is, and I'm also going to subtract 3X to both sides as well. That cancels here. So 2 is going to be equal to X. So it doesn't answer the question quite yet. All we found out is X is 2. So that means that we have that MN is 2 plus 2, which is 4. And 2 plus 1, which is 3. So ML is going to be 7. JK is going to be 2 plus, what, 6? So that gets us, what, 8? And it makes sense. 2 times 6 is 12. 4 times 3 is 12. It shows that that theorem does, in fact, work. Next, we have a concept where we're trying to look at either when your intersection's on the outside, there's a big difference in finding the value of either a tangent segment or what they call a secant, or I think that's it. Yeah. So it's just the tangent line segment or the secant of the line segment. So the first one is if you have an intersection on the outside and you are attempting to find the value of the segment whether it's on the outside, what they call the external secant, or on the inside of the circle, which they call the internal secant. Basically means that you can find any one of these values by saying that EA times it by this entire value EB is going to be equal to EC times it by this entire value of ED. So please remember that. A lot of people forget to take into account the entire line segment with that. So again, just be mindful with those formulas. So looking at this particular example, they want you to find the value of x. So to find the value of x, I'm going to say that it's going to be RP, which is 9, times it by this entire line segment, which is RQ, which is 9 plus 11, which is 20, is going to be equal to 10 times it by, again, remember this entire thing, which is going to be x plus 10. So from here, 9 times 20 is 180. Distribute on the right-hand side, so it's 10x plus 100. Subtract 100 to both sides, so I get what? 80 is equal to 10x. Will then be equal to 80 divided by 10, which is 8. So here, this is a theorem where they're asking us if you have, again, an intersection on the outside, but you have that secant here, and then you have a line that is tangent on the other side. So if you look at this one right here, it's similar to the theorem that's previous. It's the value of this segment times it by the entire value of the segment. But the only difference is now the tangent side is just be whatever this value is squared. Okay. So looking at an example problem, so RQ is tangent, RT is the secant over there. So what I'm going to say is this is going to be 16 squared is going to be equal to x times it by the entire thing, which is x plus 8. So I get 16 squared, which is 256. Distribute x squared plus 8x. Because I have the x squared, this turns into a quadratic. Anytime we have a quadratic, we have to set it equal to 0, so I'm subtracting 256 to both sides, so I got 0 is equal to x squared plus 8x minus 256. Let's see if we can reverse FOIL factor this. So I got x here, plus minus. All right, is there anything, excuse me, that gives me a product of 256, but their difference is 8? All right. So at the moment, I'm not seeing it right away. So unfortunately, I'm not going to go this route. I'm going to go the route of the quadratic formula. So again, quadratic formula is, remember, it's ax squared plus bx plus c, which these values of a, b, c are going to be relevant in the formula, which is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this particular example, b is 8, so it's going to be negative 8 plus or minus the square root of b squared, which in this case is 64, minus 4 times a, which is 1, and c, which is negative 256, and it's all divided by 2 times 1, which is 2. So looking at, so I got negative a plus or minus, so negative 4 times it by negative 256, I get 1040, so 64 plus 1024 is 1088. So I take the square root of that value and I get like 32.98. And I divide that by 2. So um, the negative one is going to be irrelevant because it's a distance value. So that doesn't. So the only one that we're going to pay attention to is the positive one. So negative 8 plus the positive 32.89 divided by 2 gets us to something about 12.49. So that's going to be my value for x, and that is our s is what they are looking for in this example. And then finally here, same idea. They want you to find the radius of the aquarium tank. So in order to find that, what they told you here is, oh, we got a tangent of 20. So this is going to be 20 squared, which is going to be equal to 8 times it by, again, remember it's the distance of this entire thing, which will be 8 plus 2r, because from here to here is r, and then here to here is r. So with that, I get 20 squared, which is 400, and it's going to be equal to 64 plus 16r. Subtract 64 to both sides, so I got what, 336 is equal to 16r. Divide everything by 16. R is going to be equal to 21, and it was feet for this example. And that is being able to look at segment relationships in circles. Hope this helps. Till next time.